Good day, everyone. In this video seminar, we are going to see about the repair of different types of the cracks. Moving forward, generally cracks has to be given attention as like what we are giving to the beams or columns. Without having this attention to the cracks, we may experience the huge collapse in the future terms. Generally, if we couldn't able to give attention to the cracks, if we fail to give attention, it leads to see the horror pictures that we have seen in our class, like shown by our map. Generally, it has two types, whether structural cracks and non-structural cracks. Structural cracks in the sense of a faulty design, in the faulty constructions or any overloading, which may enlarge the safety of the buildings. Where the non-structural cracks will created internally induced stresses. Generally, the cracks are the different types, and these types will be explained by my teammate. Over to Tamil Selvan.
Thank you, Rakesh. We can see so much of cracks. First, we can see about masonry cracks. In this masonry cracks, there are several type of masonry cracks, which can be minor cracks or major cracks, or it can requires more expensive type of repairs and a small kind of repairs. And in cause of cracks, may can happen due to the settlement or and subsidence. And the reasons that cause masonry cracks are the cracks which is formed due to the foundation settlements. The solution for the foundation settlements are the cracks which have 1.5 mm width were generally filled with crack putty, and after the crack putty the paint will be recommended. And the second one is the crack due to temperature variation. In this the cracks which is ranges from 1.5 mm to 25 mm depth, which requires uh, a solution of cement mortar or lime mortar, which is required to fill. And the third one is a crack due to shrinkage. In these type of cracks, the cracks is about 1.5 mm to 25 mm depth, which is a special type of elastic crack filling compound which is used for the solution. And the second one is a shear crack. In this type of cracks are due to the formation of a shear failure, which occurs near the beams, and it generally the cracks are formed as a 45-degree or a diagonal. It is a serial structure cracks. The reasons which cause the shear cracks are it is inadequate cross section and the shear cracks. The solution which are required for the shear cracks are the the chip the damaged crack from the structures. As we can see, the damaged sections are chipped out from the sections, and we can give the additional reinforce which are applied and epoxy coat and packed with the fresh concrete. After the concrete get harder, they apply the uh, and the third one is and cover we can apply the carbon sheets. And the third one is flexure crack. These cracks form the at the bottom of the section, which can appear at multiple cracks when tension cracks of beams occurred due to the heavy load, and flexure cracks will be formed. And the reasons for the flexure cracks are due to the tension of the beam occurs more in the bottom of the beam. The solutions which are recommended for the flexure cracks is chip the damaged concrete at the surface and place the new reinforcement with required new bars and apply epoxy coat and then packed with the fresh concrete. After the concrete get harder, apply the epoxy paste and cover the carbon fiber sheets. And the fourth one is a torsion crack. It is caused by severe inclined crack running roughly parallel throughout the length of the member. It is only an isolation part of the beam is accessible. The tension crack may appear similar to the shear cracks. The reasons for the tension cracks are the insufficient torsion and shear reinforcement. And a solution for the torsion cracks are after the removal of concrete by use of U-jack and a steel plate and packed the carbon fiber reinforcement concrete laminate around the cross sections to the depth which is equal to one sixth of the beam with along the whole span and then replaced with the new concrete. And the corrosion cracks is over to Nitish.
Thank you, Dhanshaman. So we'll be looking at corrosion cracks right now. Corrosion cracks are those cracks that happen when concrete and reinforcement does not have a proper bonding in beam. As we know, metals are highly reactive with moisture. So this happens when happen due to the growth of crack formation in a corrosive environment. This can lead to unexpected and sudden failure of normal ductile metal alloy, especially at elevated temperature. Uh, Air and water that penetrate in the beam, these form the corrosion cracks in the metal. So the reasons why this occur is when the reinforcement and the concrete are not in a proper bonding. So what we must do is the solution for this is we must remove the concrete and clean the corroded rod, that is affected rod, and add corrosion resistance bar with a good grade of concrete. Next one is the shrinkage crackage. Uh, Plastic shrinkages are caused by rapid loss of water from surface of concrete. So the time at which shrinkage cracks occur depends on its rate of drying, but it's usually several months or 2, 3, or 4 years of gas. The loss of moisture from this specific concrete results in the reduction of volume, and when this reduction is happening, shrinkage movement occurs and stresses are developed due to this. This critical condition exists when the rate of evaporation of surface moisture exceeds the rate of rising bleed water, which can replace it. The reasons for this is when the curing is inadequate, or there is no control over water cement ratio, or there is usage of excessive rich mixture. So what we must be doing here is proper curing with equal interval must be given, and proper plastering touch up on the top member. Third one is column cracks. So column cracks are divided into corrosion cracks, diagonal cracks, horizontal cracks, and splitting cracks. They happen due to faulty design construction or overloading than the design load, or corrosion of reinforcement, isolation settlement of foundation, creep or shrinkage. The diagonal cracks. Load carrying capacity of column may be inadequate, or the main reinforcement may be insufficient. The next is horizontal crack. Movement of resistance may be inadequate, or main reinforcement may not be in a proper position. Next one is vegetation crack, as the picture suggests. This happens due to the excess of vegetation. They may be cracked. They may be the root cause of the cracks involved due to the expansion action of roots that is growing under the foundation or under in the brick masonry. So when old trees are cut off, the soil that has been dehydrated earlier by roots, they swell up. They get moisture from sources such as rains, and they cause cracks in the foundation as they grow. Fast-growing trees near the footing can sometimes cause cracks involved due to their expansion action growing under the foundation. Last one is the sill cracks. Sill cracks, they occur due to the tension of windows. As we know, windows and doors are weakest part of any building. They are subjected to cracks than any other part. So this happens due to the wood swelling due to climate condition. Uh, Due to the wood expand during the temperature change, and The reason for this is wooden tension, wooden tension or wooden swelling due to climate condition, as I said earlier. The solution for this would be we should be applying crack filling and switch to steel bars. The techniques available for repairing these cracks will be taken over by Rakesh.
Thank you, Nitish. As Tamal and Nitish explained, we have seen the various cracks that has been to be noted and give attention to forwards. And for those cracks, we need to um, give with the various techniques. For each crack, we have the various techniques. So moving forward, the first one is bonding with epoxies. Generally, cracks in concrete may be bonded by injection of epoxy bonding compounds under pressure. How it can be do with the bonding? If the cracks is less than 1.5 mm width, generally it will be filled up with crack putty and paint is recommended. As Tamal mentioned in the first masonry cracks, due to foundation settlement, we could able to see that the wall has been get cracked diagonally or any horizontal crack. That might be cured by this technique. How it can be cured? Usually, the practice is to drill into the cracks from the face of the concrete at several locations. Then, water or any solvent is injected to flush out the dirt and foreign matter and allowed to get clean through the process. Then we will allow to surface them to dry. Then epoxy is injected into the drilled holes until it flows out through the other holes. Then comes to routing and sealing. This method involves emerging of cracks along its exposed surface, filling, and finally sealed with a suitable material. The image of this routing and sealing will be coming on the next slide. How we will be doing this is preferably it should be done on a pressure phase of on the water. Aggressive agent cannot be penetrate that the interior of the concrete and cause side effects such as swelling and chemical attack or any corrosion. On the road pavements, it is common to see cracks that we can see in, over the roads while passing through, which have been sealed by pouring hot tar over them. This is a simple and inexpensive way where through water tightness of the joint is not required and where the appearance is not also important. So this is a routing and sealing. We could able to see that routing is on right side and sealing is on the left side. The technique is done by in this way only. Next comes stitching. This is similar to how we are stitching to the cloth. This will be used when the tensile strength of the cracked concrete section can and that is to be restored by stitching. How it can be restored? Um, where there is a leakage of a water or any problem in the building, the crack should be sealed as well as stitched so that the stitches are not get corroded. Whenever possible, we can go for both sides of the cracks have to be stitched to prevent the bending action due to the movements of the structure. This point should be noted and give attention in the earlier stage itself. In bending members, it is possible to stitch one side of the crack only, but this should be the tension side of the section where the movement is originating. Otherwise, it is completely a non-recommended one. We should be stitched on tension side only, not the compression side. This is a stitching image that I grabbed from the internet at CV Concepts. Then comes external stressing. This will be arrested by removing the stresses. Actually, how it is happening is the developing of cracking in a concrete due to the tensile stress that has been attaining in the concrete structures, and this can be arrested by removing of those stresses. How it can be happening? These cracks can be closed by including the compressive force sufficient to overcome the tension part and to provide a residual compression. The compression force is applied by using the pre-stressing wires that what we are studying in pre-stressed concrete in this semester. And the basic principle is similar to like what we are doing in a stitching technique I said earlier. Additional anchorage are to be provided like what we are doing in a pre-stressing wires in end block designs. The compressive force also may be applied by wedging, that is the opening of the crack, and filling it with an expanding mortar, then by jacketing and grouting, or by any actually driving wedges can be used for repairing the external stressing. And this is the picture of external stressing to correct the cracking of the slab. Here we could able to see my mouse. I hope you can all see my mouse pointer. Here it is the tension tie where it can be get tension and the crack is to be repaired. And here in this picture, second picture, we could able to see that the cracking of the beam. Here it is an anchorage of both sides, and this is a tension tie to cure the beam part. Then comes the blanketing. It is similar to routing and sealing, which we have seen in the first part, but not used, but is used on a large scale and applicable for sealing both active and dormant cracks and even in joints. These blanket joints has four types. First one is an elastic sealant filled joint. This is where an elastic sealant is used, where the sealant material is the one which return to its original shape when the externally induced stress is removed. Second one is the mastic filler joint. These are used in where the anticipated movements are very small. Then comes the motor plugged joint and a crimped water bar, which we are using in a very normal way. Then comes the overlays. Obviously, it is used to seal the cracks. These technique are useful and desirable where there is a large number of cracks that we are finding in the structures. Epoxy should be used to bond the overlays to the existing structure. For overlays, pneumatically applied mortar, sand, cement slurry, epoxy resins, bituminous coating, and ferrocements are used. For active cracks, sealing of an cracks by use of overlay should be extensible, but it should not be flexible. Coming to the dormant cracks, any type of overlay may be used to seal the dormant type of cracks. Then comes grouting. This is a very famous method that we are studying from undergraduation. It can be performed to a similar way that how we are doing in the injection of epoxy. However, the use of an epoxy is a better solution, except where the consideration for fire resistance or cold weather prevents from such use, in which case grouting is comparatively alternatable. The alternative method is to drill down the length of the crack and grout it so as form of a key, and this is applicable only when the crack runs approximately in a straight line and accessible to one end. Otherwise, it could be a very difficult way to cure the cracks. Then the grout key functions to prevent an relative transverse movements of the section of the concrete to the adjacent of the crack, and it also prevents a leakage through the crack. And this is a grouting process. Then comes the autogeneous healing. What is autogeneous healing? The inherent ability of a concrete to heal the cracks by itself. The name itself, it is saying that autogeneous healing. That means the crack is healing automatically. This is used to sealing the dormant cracks, such as the repair of a precast units cracked in a handling or reconnecting of cracks developed during the drilling of a precast piling or in work that we are going to be happen. Sealing of cracks in a water tank or any sealing of cracks which is result to a temporary conditions that we are working for. This effect also provides some increase in strength of a concrete damaged by vibration during setting and concrete distributed due to freezing and thawing also. As a result, some of the tensile strength is restored across cracked section and the crack is to be get sealed. This picture explains the autogeneous healing. Here the white line, you could able to see that the crack is healed by themselves, and also we could able to see that the other side of the two cracks where I am pointing the mouse pointer, the new cracks formed during the reloading adjacent to the heated up crack, and this should be noted. And conclusion point, over to Nitish. Nitish?
Thank you, Rakesh. From the above mentioned discussed topics, we have seen that we have seen the types of cracks and techniques to repair the cracks. So, in a structure, cracks are inevitable, but this necessarily does not have to have any effect on structure stability. Distress in structure is witnessed as cracks. They may be active, structural, or non-structural. As far as possible, any active crack must be made dormant, that is, they must be made inactive by finding its cause and taking measures so that its effect is minimized or eliminated. They must be repaired with suitable technique that has been discussed by previously discussed. But however, good practice of usage of material, equipment, and skilled labor is necessary to prevent the cracks from even occurring. As we know, prevention is better than cure. References will be discussed by Rakesh.
Yes, thank you, Nitish. As Nitish and Tamil explained, we have seen the various type of cracks and the techniques that we have adopted. Even though we are structural engineers, we could able to suggest many type of cracks and repair techniques, but we could not able to repair our own cracks that has been happening in our home. Yeah, cracks should be get attention in an earlier stage so that the future collapsation or any unavoidable situation can be avoided. Techniques are vast and are available in the industry, but those techniques are not practiced by the skillful laborers that is demanding in this in our country especially. And these are the references that we took from the guide of stinkage in concrete for masonry walls, and case study from the prediction of cranking in the reinforcement concrete structures, and also from the IS code Indian standard for calculation of crack from the appendix X and SP25 handbook. Thank you, Nitish, and thank you, Tamil Chelvan.